Hey everyone, it's Rudy Hill here. I've been an FPGA engineer for the last 5 years, and I am striking while the iron is hot right now. So I just finished talking about an inverter, and I kind of mentioned some basic logic, and I kind of figured, what the heck? Like, let's just do basic logic. We're not going to do anything crazy yet, maybe for another video. But yeah, let's just get into it because I don't think it's that hard, and I think it's pretty easy to understand. So let's just say that we have a statement P. This is where we'll start. So let's just say the statement P is something like the sky. First, I should spell right. Uh, the sky is blue. Great. Now, if I say the sky is, this is something very unnatural. Let's just say it's green. Maybe it's pink. I've seen the sky pink. I've seen the sky orange. I've seen the sky in a lot of colors, but I'm not sure I've seen it green, or it's not supposed to be green, at least. Um, but for the sake of argument, we'll just kind of go with these two very basic statements. So let's just say that P is the sky is blue. We would say, hey, that's true. Again, we're not going deep into this. We're just kind of using a very basic example. But yeah, the sky is blue. True. Okay. The sky is green. We'll say, for the sake of argument, that this is false. Okay, so now we have the very basic like language of logic, whether something's true and whether something is false. Cool. So these are examples of statements more than anything. P can represent any statement. It's kind of like a variable, we'll say. And we could do that with anything. We could say that there's a statement Q, and we can say that um, I am on Earth. And just trust me, but this is true actually. I could also say that I am on Mars. This is false. I'm not on Mars. Okay, so you're probably thinking like, hey, like I understand statements. I understand truth or not, and we're talking about well-defined stuff. This is just an example of statements. I should add. So really, I want to introduce to you two concepts: um, ands and ors, and statements, or statements. And I want to introduce to you truth tables, and we kind of introduce them at the same time. In fact, so we'll say that we'll talk about this concept of and. What does it mean if you have two statements and, and you and them versus if you have P or Q? So, and usually we could denote this logically with P or Q, P and Q, and then P or Q. So, when we say that a statement, let's just say, I'm not sure what the terminology is, but we'll say this is Z. P and Q pretty standard. I forget what it is, but what does it really matter? We'll just call it Z. So let's just so we have to kind of talk about truth tables. So this is pretty. This is set up pretty well. So when we say that things are anded, we're talking about this as a statement itself, right? So let's just say false, two false statements. And we're kind of just building up a table here of P and Q. You can probably see that. And then what Z is. So if P and Q are false, then Z has to be false. If P is false and Q is true, Z is still false. If P is true and Q is false, Z is still false. But, and this is the important of and, both P and Q have to be true for this statement, P and Q, to be true. So for Z to be true. So this is the example. We'll kind of go through this. The sky is blue and, so that's P. The sky is blue and uh I am on Earth. So if you say like, is it true that the sky is blue and I am on Earth? Is that statement true? Yes, it is. But what if I say if any one of those is false? It's false. Okay, the sky is green and I'm on Earth. Okay, that's we're it's an and. So no, that's not true. One of those statements is true, but the overall statement is not true. Okay, the sky is blue and I'm on Mars. Okay, that's again that overall statement is not true. And obviously, if I say the sky is green and I'm on Mars, that statement is false. So that's kind of the basic intuition for this. And or if I've explained all this, but this is all mathematical, and you should already be familiar with this from day to life. Um, does this sandwich have ketchup and mustard? No, it only has mustard. Does it have ketchup and mustard? No, it only has ketchup. No, it doesn't have either. And so we're gonna get to like ors, which is gonna be a very similar discussion. So let's talk about it. Let's make this truth table. So of course, yeah, you can see that P is matching up here, and Q is going there, and Z is going in the last column. So okay, we have P or Q. So if P or Q are false, Z is false. Okay, let's say that if P is false but Q is true, then the statement is true. And if we say, okay, P is true and Q is false, Z is also true. And finally, if both statements are true, Z is obviously true. So this is the basic truth table. This is basically everything I want to teach you today is ands and ors and statements being false versus statements being true. So we can kind of go through. So we say the sky is blue, or let's just start with the false statement. Let's go through in order. The sky is green, or I'm in Mars. Neither of those are true, so it's false. So the sky is blue, or I'm on Earth. Sorry, the sky is green, or I am on Earth. Oh yeah, that's true. Um, the sky is blue, or I'm in Mars. Again, one of those statements is false, but it's still true overall because we're saying or. Because saying or, like one of these has to be true. And of course, if I say that either the sky is blue or I'm on Earth. Okay, well, both of those are true, so overall it's true. Um, this is um, this is the very basic intuition for this. This is very basic building blocks, the common sense. Because overall, when we're talking about ands and ors, we can kind of set up these structures without knowing if P or Q are true to begin with. They're like variables. That's the kind of way to view it. They're variables, and we can kind of use these things and stack them. So um, we can even build up truth tables. And I'm just gonna make one up, and then we'll kind of go through it together and kind of see if it's true. Um, let's get fancy here. Let's say P P and Q. Um, P and Q or Q. I think we might get something very interesting here, but I don't know. I'm just making this up. So this statement, if we have P, Q, we set up our truth table. Let's say this is Z once again. We'll kind of just go through it. So let's just say, well, our very basic permutations: false, 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 true, true, false, false. Sorry, true, true. So if we say that false, false, and false, so that's false, or This is false. This is going to be false, right? So that's kind of how we use this logic here. Okay, so P and Q. So this is going to be false, right? And then Q is true, actually. So one of these is true. So, like, when I build the parentheses, you kind of understand. It's like logic, like just like with math. It's like, you do the parentheses first. So that's kind of how we're evaluating. I didn't mention it, but it's kind of implicit. Um, so we say, okay, so one of these is true, actually. So Q is actually true. So it doesn't matter. Um, and then we do true. Okay, we'll say that P is true and Q is false. So this is true and false. So this is overall false, but Q is false. Um, so this is false. Um, and now we say true and true. So P and Q, that's true. And with Q is true. Now we say that this is true. So this isn't even really any break. You can't really break down this logic anymore with this truth table. I'll kind of redraw it. But basically, these P and Q are the inputs, all the possible inputs, and we kind of just drew out um, the possible outputs. So yeah, this Z, this isn't really mappable. This isn't reducible. At least it's not something I can recognize. And reducing is something we'll talk more down the line with. We'll say actual Boolean logic, Boolean algebra. I think this is technically Boolean logic, but Boolean algebra, there's a math to this where you can kind of chunk this together. Um, More formally is maybe I'm not as familiar with trues and falses, but as a digital designer, maybe that's why I mentioned at the beginning I'm a FPGA engineer. I'm more familiar with zeros and ones, which is more you can actually implement that with circuits. But this is more mathematical, more conceptual. So I kind of just made this up on the fly, but this is kind of how you can build up ands and ors, and like I was kind of alluding to, is sometimes you can actually like recreate the same kind of logic that you can reduce. But that's pretty much it. If you're more interested in this particular topic, I guess I'll make more videos, more pertinent to digital design. But if you're more curious on some of the math side, and we can talk about that more, so drop a comment, I guess. And like if this is helpful, I got a couple more videos to make regarding this topic and similar topics. So here you go to review. All right. Thanks for watching.